Okay, I think the last video timed out on us, so we're going to start this video up again. Because the circumference of your circle is 2 pi r, there are 2 pi radians in a full circle. So this following part we can kind of start as being kind of important. We can look at the relationship between degrees and radians pretty easily. Since there's 360 degrees in a full circle, we also know that there are 2 pi radians in a full circle. The relationship between angles and degrees can be easily found by dividing both sides by 2. And since 360 degrees divided by 2 is 180, we can look at the relationship between radians and degrees using this type of equation. Pi is equal to 180 degrees. The diagram to the right shows the equivalent radian and degree measures for special angles. So you've got all your special angles that are part of your current unit circle, and the pi's and the fractions all the way around kind of represent the radian measures of those special angles. And we'll get into this a little bit more on the back side of this sheet. But just kind of know and mark down that pi is equal to 180 degrees. Flip your sheet over on the back. We're going to do a couple examples to get you set up for class tomorrow. We can use the following rules to convert degrees to radians and radians to degrees. So since you know that 180 degrees is the same thing as 1 pi, or pi radians, we can use a conversion, and we can write it 2 different ways to represent this relationship. If we're converting degrees to radians, we're going to multiply by the proportion pi over 180 degrees, and we can write it this way. And if we're trying to convert between radians and degrees, so we're going the other way now, we can write it as 180 degrees over pi, and we'll talk about this in just a second. So there's 2 conversions that we can use depending on what we're trying to convert to. Remember, degrees and radians mean the same thing, kind of like fractions and decimals, but they're in 2 different forms. So they take on the same meaning, but they're in 2 different forms, and we can convert easily between the 2 using these 2 conversions depending on what we're trying to do. So let's look at example 1, converting between degrees and radians. So let's say you guys are given that pi over 8 radians on a unit circle, and you want to convert that to degrees. You have no idea what pi over 8 means in radians, and you want to know kind of what that number represents in degrees. We can do that using our conversion charts above. So the first thing that's important to remember is that you've got your pi up in your numerator and you've got your 8, or whole number, in your denominator. So which of these 2 do we want to pick? Well, of course we're going from radians to degrees, but sometimes it might be a little confusing as to which one to use. So this rule of thumb has always worked well for me. So obviously we're going to have a conversion where we have a numerator and denominator, and I have to pick between these 2. Because we're trying to cancel out our units of radians, we're trying to get rid of pi to give us a value in degrees, I want to make sure I set my pi values on a diagonal so that they cancel. So if I'm looking at these 2 conversions up top, I want to pick the one that has a pi in the denominator so my 2 pi's can cancel. So out of these 2, if I happen to forget which one goes to which to convert, I want to pick the one conversion that has the pi in the denominator. So I'm going to go with this guy. So pi over 8, I can convert to degrees by writing my conversion as 180 degrees over pi. And once I do that, I have my pi's on my diagonal, so those 2 cancel. Once pi cancels up here, the 1 of placeholder is put in its place. 1 times 180 is 180 degrees, divided by 8 times, I have another 1 for a placeholder, 8 times 1 gives me 8. And if I take 180 divided by 8, that represents, or will convert down to, 22.5 degrees. So pi over 8 radians is the same thing as 22.5 degrees. Let's look at these 2 checkpoints down below. Okay, we're going to do both of these together. We're going to kind of build off of example 1. so that you guys are ready for class tomorrow. So in both of these, numbers 1 and 2, the checkpoint asks us to convert the degree measure to radians and the radian measure to degrees. So whatever you're given, you want to convert it to the opposite. So since we're in degrees here, we want to convert this degree to radians, and we want to convert this radian to degrees. You know that you're in radian form whenever you have the pi that's next to it, or given within your value. So in this guy right here, I know I'm going from degrees to radians. So I know I have the proportion of either pi over 180 degrees or pi, 180 degrees over pi. Those are my two forms of my conversion. So I have to pick whichever one works best in my situation. Since I'm given degrees in number 1, I want to multiply by the conversion that has degrees in my denominator. So again, 270 degrees can be rewritten as a fraction over 1. And since I want to cancel my units on my diagonal, I'm going to pick the conversion that has the degree on the diagonal so that they cancel, which would be this conversion. So pi goes up top, 180 degrees goes on bottom. Since your degrees are on your diagonals, those two can cancel, and if I multiply across, I get 270 pi over 180. If I go through and I cancel, or I try to simplify, the zeros can cancel out. 27, which gives me 27 pi over 18. And if I simplify that one more time, 9 goes into both of them. So if I divide 9 on